All right, let's go over this progress check over inverse functions and transformations of radicals. I'm just going to go through kind of how to think through each question, and then, of course, let me know if you have extra additional questions. So you can always fast forward and just go to the question that you need to go over, or you can watch it all if you want. This says determine the domain and range of the function. It's a negative square root function. You don't have to do a whole transformation table. I didn't give you that kind of space, but we need to know which way the graph shifted and which way the graph points. So we need to look at our transformation, specifically our shifts. So I'm going to factor this 2 out from the middle. Be careful here. It only shifted to the right by 3/2 or 1.5. The plus 1 at the end still means it shifted up 1. So this graph shifted over 3/2, which is 1.5, and up 1. That's its new starting point, and it reflected over the x-axis, a vertical reflection. So instead of being an increasing square root graph, this graph still points to the right, but it's decreasing. So its domain would be, it starts at 1.5. I get to include that. It continues to the right. The range, make sure you're listing them from least to greatest, would be -infinity up to 1. If you'd rather use inequalities, that's fine. It didn't specify. So you could have said x is greater than or equal to 3/2. Y is less than or equal to 1. Either of those are fine. Okay, number 2. Given the function f of x equals the square root of -x plus 2 minus 13, what is the minimum value of the function? So that means what is the lowest y value? So let's take a look at the transformations. I would still have to factor a negative from this problem. So I can see that it's negative x minus 2 minus 13. This is shifting down 13, right 2, and reflecting over the y-axis. Okay, so let's draw that picture. Ooh, right 2. Okay, so it doesn't really matter. Right 2, down 13. And then instead of being an increasing graph, it got flipped over the y-axis. So now it's going to be pointing to the left. So it looks like the lowest it's going to go is -13. Now I noticed one of the answers said no minimum value. An example of what that would look like, because some people asked, would be if you have a starting point of your graph and it's decreasing, like the first example up here, this one has no minimum because it keeps decreasing. It only has a maximum value. Okay, so let's look at the next one. Same, relying on transformations, these first few problems. 3 says, it gives us kind of this crazy equation. What is the domain of f of x? Well, hopefully you noticed that we've been looking at inside the square root, looking at where does that graph actually shift. So if I do that here, it looks like x minus 2c, this would be shifting to the right by 2c, even though I don't know what c is, that's okay. It's already factored. So this graph would start at 2c, and so the answer here should have just been A. So it's like the normal parent function that starts at 0, 0 and increases with a domain of 0 to infinity, has got shifted to the right or gotten shifted to the right by an unknown value. So it's going to look the same. It would just start at 2c instead. Okay, 4, most missed question right here. It says that we have a cube root function, and then we have to reflect it over the x-axis. We have to do this transformation first. So I'm going to look and see. It's a different shape. The cube root function goes through 0, 0. There's kind of a roughish sketch of one. But this one here, let's look at its current transformations. Underneath the cube root, I would have to factor and see that it has 2 times x plus 3 minus 1. So currently the center point, instead of being at 0, 0, like this one over here I sketched, the center right now is at -3, -1. The other transformations here, like that 2, it's not going to be too important right now when I sketch it. So currently -3, -1. Okay. And then I'm going to look and see if we flip it over the x-axis, this reflected point will become -3, +1 over the x-axis. And so there we go. We're going to have some sort of reflected graph, which I then have to shift to the left by 3. So instead of being at -3, +1 now, shifting it left 3 more is going to put it at -6 and then up 2. So I'm going to shift it on over. Let me get a different color so it doesn't look like such a mess. I'm going to have to shift it 1, 2, 3 to the left, up 2, and that new center point of my graph, not my best graph, I apologize, but it's going to be -6 and +3. So I'm going to cross off A. It doesn't have a +3 at the end. I'm going to cross off C because C has a reflection over the y-axis, a horizontal reflection. So out of B and D, neither of them have a 6 because think about the inside, we would have to factor. So if I factor the 2 out, this one shows that this graph overall has been shifted left 6. It starts at -6 and +3, and it has the reflection over the x-axis. D is the correct answer. So if you just changed the 3 only on the inside, a lot of people picked B. Some people picked A because you weren't thinking about flipping the whole graph over the x-axis before shifting it. Which section? Section 4 of the spiral review has some questions where you can practice this. Okay, number 5, write the equation of the inverse of f of x. So you have to know what this symbol means, what this notation stands for. Given a quadratic equation, it has a domain restriction. So remember, less than or equal to 5 is the left side of this parabola, this quadratic equation. So our first step when we find the inverse is to switch the x and the y in the equation. And now we want to isolate the y. So I'm going to add 1, x plus 1 equals -2 times y minus 5 squared. We're trying to get the y minus 5 squared by itself. So I'm going to divide it all by -2, and I can really just leave it like this. X plus 1 all over -2 equals y minus 5 squared. Now I can take the square root of both sides, but I don't want to put plus or minus here. I have to choose if it's the positive or negative square root based on the restriction. The left side of the parabola always corresponds to the negative square root. So this is going to just be the negative square root of x plus 1 all over -2 equals y minus 5. I'm going to add 5 at the end. That can't enter the square root, so it's just going to go after the square root. Notice the -2 is under the square root. And now that y is isolated, I'll just go ahead and use my inverse notation. So I could make this slightly clearer right here. that the 2 is underneath that square root. And that would be my final answer. So if you forgot to put the negative, you would lose partial credit. And of course, if you got lost in your steps along the way, you would lose points also. Okay, the next one was one of the most missed questions. It says, sketch the graph of the inverse of f of x. So you have a couple options. You could sketch f of x. Some people chose to do this. Sketch the square root and then switch all of its x and y's. You could also, some people chose to find the equation. So they chose to take the square root of y plus 4, switch the x and y, subtract 1 on both sides, square both sides. So I get y plus 4. And then don't multiply this side out. A lot of people tried to FOIL this and then got confused. Leave it how it is. Subtract the 4. It can't enter the parentheses. It's not being squared. X minus 1 squared minus 4 is the inverse. But technically, this is a full parabola. And we know that doesn't pass the horizontal line test. So since you were given a positive square root at the beginning, it corresponds with the right side of the parabola. So let's look at this equation and see. It's been shifted, right? 1 up 4. It's a quadratic equation. Right, not up 4. Take that back. Right 1, down 4. So its vertex is at 1, negative 4. And we want the right side only. So you didn't have to write this on your paper, but the restriction that we need is x is greater than or equal to 1. And then you could just show me the general shape. You didn't even have to do all the specific points. So that's what I was looking for, some sort of work to show your thought process, and then half of the parabola. Some of you made a transformation table, and it was beautiful. And you then sketched f of x only. So some of you had the points, let me see if I can remember. Negative 4, 1. You had the point like negative 2, or negative 3, 2. 0, 3, etc. Some of you had this sketched. I'm going to just put it as a dashed line. This is the original graph. So another thing you can do here, if you graphed the original, just switch all those ordered pairs. So instead of the point negative 3, 2, my new graph should have the point 2, negative 3. And I didn't do a great job here, but it should have the point 3, 0. So again, the blue one that I graphed is the answer we were looking for. Okay, on the back. Oh, 2 of these. Okay, now on the back. Use composition of functions. If you did not show composition, f of g of x, we have to show that that equals x, and g of f of x. We have to prove that that's going to equal x as well. If you didn't do both, then, or if you didn't do either, you really lost a lot of points here. You can't just find the inverse. Okay, so let's do f of g of x. I'm going to plug all of g of x into function f. So it's going to be 4 times negative 16 plus x over 4, and then finish out the equation with the plus 16 at the end. Some of you distributed and then didn't divide correctly. What would be easier is to just say times 4 divided by 4 cancels. So I'm left with negative 16 plus 4. Or not plus 4, sorry. Negative 16 plus x plus 16. And the 16s cancel. And I get x. This is half proven. So now I need to do g of f of x. I need to plug function f into function g. So negative 16 plus 4x plus 16 all over 4. Even if you put this in parentheses, there's nothing to distribute, so you're allowed to just go ahead and say the negative 16s are going to cancel, or the negative 16 and positive 16. I get 4x over 4, which leaves me x. So then you need to have some sort of yes or no answer. Yes, they are inverses. If you just put the word yes, that's fine. Okay, so then on the second one, we have h and j, and that doesn't matter. You can plug them in either order. I guess I'm doing j of h of x first. So I'm going to plug h into function j, negative square root of x squared plus 4 minus 4. Oh, sorry, I don't know why my 4's and x's are getting confused here. So I have the negative square root of x squared. Don't need all this extra space. The square root and the squared cancel, and I'm left with negative x. So therefore the answer would be no, or they are not inverses. And you should kind of be able to tell here, right? Because here I have a quadratic, it's not restricted, and then here I have like a negative square root. So that should kind of tell you that you probably have some issues. So do make sure that you show the composition to get full points on the test. Okay, a transformation table. You only have to know your square root transformation table for the test. Here are your starting points. Remember, we don't want to put any negative x's because you can't take the square root of a negative without getting an imaginary solution. So these first two columns are you showing me y equals the square root of x. So if we take the square root of 0, we get 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Right? Your y's are counting by ones, and your x's are all perfect squares that give you this value. Okay, the transformations. The other part that was missed still is noticing that under the square root, there's a negative that has to be factored from that expression. So that negative means I'm actually shifting to the right by 2 once I factor it out. Here I have a horizontal reflection, or ROIA, and then minus 1 at the end. So my transformations are a horizontal reflection, or you can say reflect over the y-axis. Right 2, both of those are going to affect my x's, and then down 1 will affect my y. So the y transformation rule is really easy. There's only one vertical change. The x's, to reflect them, we need to make them negative. To shift them to the right, we need to add 2. So in this one really random case, or unique case, what I have in my table is the same as the equation. But it's only because we have that negative 1 with x that happens in this case. Okay, let's plug in our original x's. So I'm going to be plugging these in, writing the answer underneath. 0 plus 2 is 2. Negative 1 plus 2 is 1. Negative 4 plus 2 is negative 2. Negative 9 plus 2 is negative 7. And then I'm going to subtract a 1 from every current y. And then I'm going to plot these. 2, negative 1, 1, 0, negative 2, 1, negative 7, 2. And then if you're like, what does this look like again? remember the first one is your new starting point, and the last point tells you kind of where the graph is going to continue. So start at 2, -1, connect your points, and draw an arrow after the last one. Because this got horizontally reflected, it points to the left instead of to the right. And now that I have my graph, it's easier to analyze the domain. It looks like -infinity. The furthest to the right it goes is 2, which I get to include. And then my y's, the lowest it goes is -1. And it continues to infinity. Do expect to see a similar transformation test or transformation table on your test. All right, y'all, last two. These weren't missed as much, thankfully. 9 says the graph of y equals the cube root of x is horizontally compressed by a scale factor of 4, shifted up 5, and reflected across the y-axis. What is the equation of the translated graph? I didn't take off, but equations have to have an equal sign, so you should have started with y equals or f of x equals. It's up to you. I have 2 changes that are horizontal. Reflecting over the y-axis is actually a horizontal change, right? Flipping across the y is a left and right change. So underneath my cube root, I'm going to have to reflect them, and I know that a compression is actually going to be the reciprocal. It's going to, in my equation, appear as a 4x, so it looks opposite. And then I need to shift it up 5. So clearly that plus 5 needs to be written outside of the cube root. Don't make me wonder if it's inside or not. And that's it. Okay, last one says find the inverse of the given function algebraically. It's quadratic, so it's a parabola. X is greater than or equal to -3. It means it's giving us the right side. Okay, so here we go. Switch x and y. X equals y plus 3 over 2 is being squared minus 1. Okay, let's get the y by itself. So I'm going to cancel the -1. X plus 1 equals y plus 3 all over 2 is being squared. And now I can take the square root of both sides. And then here's where I have to decide. It's not plus or minus. You choose, because it's the right side only. We need the positive square root. So just writing it as the square root of x plus 1 is good. Right? It is positive. And I'll assume it's positive if you don't put a negative. Okay, now that I don't have that expression being squared, I can go multiply both sides by 2. Now, some people tried to multiply by their 2 inside the square root, and that can't happen. So it's just going to be 2 square roots of x plus 1, and at the very end, we can subtract this 3. Oops. The 3 cannot enter the square root, so it's going to be 2 square roots of x plus 1 minus 3. Now that y is by itself, you can show me that you found the inverse by using inverse notation. Okay, hopefully this will help clear up some questions, and then of course you can still let me know if you have additional ones.